Today we will discuss about chapter 8. In this chapter 8, we will discuss about uh, fraction. How can we express a fractional part with each other? No annotation, no space is allotted. So we will discuss about the fraction. How can we express the fractional parts? We will discuss at first it. So let's go. We see that there is a 1 meter long string and it is divided into 3 equal parts. How can we express this length in meter? You see that there is a 1 meter long string from here to here. This is 1 meter long. We divided this 1 meter long string into 3 equal parts. We divided from here and from here. All 3 parts are equal. How can we express in meter every parts? So we see that the 1 meter long string divided into 3 equal parts. So 1 meter is divided by 3. So every part contain 1 by 3 meter. So we can write from here to here is long. The string is 1 by 3 meter. From here to here 1 by 3 meter, and from here to here is 1 by 3 meter. This part is called 1/3 of meter because they are divided into 3 equal parts. So every part is called 1/3 of 1 meter. This is 1/3 of 1 meter. This is also 1/3 of 1 meter. So all are equal. When we can write these parts, we can write 1 by 3 meter as like that. Every part is expressed in meter. In this way, we can express the fraction part. When we divided equal part of 1 meter, we can express it. Any of length, when is divided how many parts, you can write or express the total length divided by number of parts. So next slide, we see that how long are the color part. We have to identify how long the color part and write in the backend box. We see that from the beginning portion and from the ending portion, there is 1 meter long string. We see that there is from here to here is yellow color. That means it is divided into 2 equal parts. One is white and another is yellow. Here 1 meter is divided into 2 parts. So 1 meter divided by 2 meter. So every part is equal 1/2 or 1 of 2. That means half. That means 1 by 2 meter. So the yellow part is 1 by 2 meter. And the white part also 1 by 2 meter. In this way, we can express the fraction. In number 2, we see that 1 meter long string. From here to here is 1 meter. You see that this is 1 meter long. But this is divided into equally 5 parts. 1, 2, 3, 4, and 5. So 1 meter divided by 5 parts. So every meter contain 1 by 5 meter. So this color area contain 1 by 5 meter. Not only the color area, every part is 1 by 5 meter. This part is 1 by 5 meter. This is also 1 by 5 meter. And this is also 1 by 5 meter. In this way, we can express the coloring part or divided part of any length. This is expressed as a fraction. So in the next math, we see that color a part of expression 1/4 meter. You have to color it. So we choose at first, we choose a red color for coloring. We express in 1/4 meters. So from the beginning to end, this is 1 meter. It is divided 4 part, equal 4 part. So every part contain 1/4 meter. This part is also 1/4 meter. This part is also 1/4 meter. This is 1/4 meter, and this is also 1/4 meter. But you have to color 1/4 meter. So we can color it by choosing a red color in this part. So red color is coloring the part whose area, whose length is 1/4 meter. But other students say I will color the another 1/4 meter part. So he can choose the another color. It would be yellow. So he choose this part will be yellow color. And this part is yellow color. So both are right because the red part is 1/4 meter, yellow part is also 1/4 meter. Other students say I will color blue, the 1/4 meter. He colored the third part, the blue color. So he is also right because this part length is 1/4 meter. All part are equal. Other students say no, I will color pink. So he can select the last part of the length, part's length. So he can color the pink color, the last part. He is also right because every part has equal length. In this way, we can express 1/4 meter by coloring. So let's go the next math. How can we express 2 pieces out of 3 equal pieces of 1 meter? 2 pieces. You see that there is a string from beginning to length. This is indicated by 1 meter. But you have to express 2 parts equal. So you see that they're divided into 3 equal parts. One is from here, another is from here. But you have to express from here to here. This is 2 parts. How can you express? You see that when 1 meter is divided into 3 equal parts, so this part is contained 1/3 meter, this part is also 1/3 meter. So 1/3 meter and this part also contain 1/3 meter. So when we add, we get 3, 1 plus 1, and we get 2/3. That means 2 part of 3. 2 piece of 3 equal piece. So this 2 part from beginning to here, we can write this part contain 2/3 meter. Because the string length from beginning to end is 1 meter, we divide it into 3 equal parts. So we have to express 2 pieces length. So we can write 2/3 or 2 is of the third. So we can express in this way. So 2 pieces out of 3 equal pieces of 1 meter is called 2/3. of 1 meter. It is written as 2 by 3 meter. Then when we express all parts, then 3 parts, so we can write 3 by 3 meter. 3 by 3 meter, that means 1 meter. So it is, that means for 3 by 3, that means whole length of the string. In this way we can express the length of something. So in the back end portion we have to write 2 by 3 meter. The two pieces, the length of the two pieces of out of 3 equal pieces. Color the following parts. You have to color 3 by 5 or 5 by 8. You have to color it. You can see that this is the length divided into equal 5 part. 1, 2, 3, 4, 5. 3 by 5, that means 3 part of 5. So 3 part of 5, it may be from here to here. So anyone can color the red this part to from here to here. This is the 3 part of 5. This coloring with red. We divide it from here and from here. And other students say, no, I will color another portion. So he can select the another color, it will be black. So he can color from here to here at last end. This is also 3 part of 5. He can color it black. In this way, in two ways, student can choose the 3 part of 5. The last section, 5 part of 8. So anyone can choose 1, 2, 3, 4, 5. So he can choose black color from end to here. And we divided from here and here and here. So it will be black because one student choose, he colors the in black in color paper. Other student choose, no, I will color the blue. So he can choose from here to here. This is also 5 part of 8. So it will be 5 of 8 parts. He can choose this color. So anyone can choose this way. So this is the so number like 1 by third, 2 by 5 are called fraction. This is called fraction. The number as like 1 by 3 or 2 by 5 are called fraction. So 3 and 5 are called denominator, and 1 and 2 is called numerator. You have to remember, as like a fraction 1 by 3 or 2 by 5, these number are situated in the below under the line. This is called denominator. This number is upper of the line, fraction line. This is also called numerator. So 1 by 4, here 1 is numerator and 4 is denominator. In this way, we can express our fraction. So let's next math. You have there is a math. You have to indicate if a number is numerator, then the surround with the triangle. if a number is denominator, then surrounded with circle. So there is an example 1 by third. This is 1 is a numerator and 3 is a denominator. You have to identify it. So we can choose numerator and denominator by indicating the triangle and circle. 4 is numerator, so we can write a triangle. 1 is numerator, so we write a triangle. 5 is numerator, so it will be under the triangle, and this is also triangle. And 5 is the denominator, so this is under a circle. 7 is the denominator, so this is under circle. 8 also denominator, and 9 also denominator. In this way, we can identify the denominator and numerator in a fraction. So in the next slide, there is 2 math. Write a fraction that has 9 as a denominator and 5 as a numerator. And you already know numerator go upper of the fraction line and denominator will be under of the fraction line. So we can write 5 by 9. So here 9 is denominator and 5 is numerator. And number 7, solve the question related to the following diagram. There is a length from 1 meter. You have to write in box with the fraction. So we can see that there is a 5 part, 1, 2, 3, 4, 5, 1 meter. So every part contain 1 by 5 meter. 1 by 5 meter. So this part will be 2 by 5 meter. And from beginning to here, this is will be 3 by 5 meter, and this also will be 4 by 5 meter. So write the fraction in the box. Already solved the number 1. Number 2, where is 5 pieces of 1 by 5 meter on the number line above? Where is 5 piece of 1 by 5 meter on the number line above? You have to indicate this portion. So we can indicate this portion where 1 by 5 meters length. And the which is longer than number, this is the 1 by 5 meter. Where is 5 pieces of 1 by 5 meter on the number line above? This is 1 by 5 meter, this portion. Which is longer, 3 by 5 or 2 by 5 meter? You see that here is from the beginning, from here is 2 by 5 meter, and from beginning to here is 3 by 5 meter. So from the physical, we see that 3 by 5 meter is longer than the 2 by 5 meter. So we can write 3 by 5 meter is longer than the 2 by 5 meter. In this way, we can change our identify our fractions line. Let us the following fraction in the upper fraction. We see that they are divided into 2 parts. That means they are divided 2 parts. So 1 by half are divided from here, and from beginning to the last, and this is 2 by 2. In the last, they are divided into 4 parts. So we can write here 1 by 4. We can write 2 by 4. Here is 3 by 4, and here is 4 by 4. So we have to find out the equivalent fraction. We see that this is 1 by half is length from the beginning from here to here. In the second part, we see that from the beginning, we see that from here to here is the length 2 by 4. So this length and this length is same. So we say 1 by 2 is equal to 2 by 4 because they are same length. So these two fractions are equivalent. And also we see that from beginning to last end, this is 2 by 2. And in the second part, we see that from beginning to last end, this is 4 by 4. So we can write these two parts is equal. So they are 2 by 2 and 4 by 4 are equivalent fraction. And here 1 by 2 and 2 by 4 is also equivalent fraction. Because when you divided this fraction 2 by 2, we get in the upper is 1 and in the below is 2. So this is half and this is half, so they are equal. When you divided 2 by 2, you get 1 full length, 1 meter. When you divided 4 by 4, you also get 1 meter, that means full length, so they are equivalent fraction. In this way, we can identify the equivalent fractions. We have to write the denominator and denominator. Here denominator is 2, 4, 6, 8 and 10, and you have to write the fraction. So in the first part we see that there is 2 part, denominator 2, so I also divided into 2 part, so we can write here will be half. This is divided into 4 parts, so this will be 1 by 4, this will be 2 by 4, this will be 3 by 4. Here denominator 6, so divided into 6 parts, so we can write this is 1 by 6, this is will be 2 by 6, this will be 3 by 6, this is 4 by 6, this is 5 by 6. We can write the last 10, so this is will be 2 by 2, this will be 4 by 4, this will be 6 by 6. They are divided into 8 parts, so we can write 1 by 8, this is 2 by 8, this is 3 by 8, this is 4 by 8, this is 5 by 8, this is 6 by 8, this is 7 by 8, this is 8 by 8. We can write here this is 1 by 10, this is 2 by 10, this will be 3 by 10, 4 by 10, this is 5 by 10, this also 6 by 10, here will be 7 by 10, this is 8 by 10, this is 9 by 10, this is 10 by 10. All the fractions you can see same length, so this is our equivalent fraction. So 2 by 2, 4 by 4, 6 by 6, 8 by 8, 10 by 10, equivalent fraction. There is also some equivalent fraction. This is because you see that 1 by half, 2 by 4, 6, 3 by 6, 4 by 8, 5 by 10, all are same length from the beginning point. So all are equivalent fraction. In this way, we can find out the equivalent fraction. They are equivalent. So our next math, we see that we have to find the equivalent fraction. We already seen how we can find the equivalent fraction. If we look at half and 2 by 4, how can we understand the two are equivalent? we can understand in this way. At first you have to write in this way: half and 2 by 4. You have to multiply the denominator of one fraction and numerator of one fraction. That means 2 and 2. This 2 is the denominator of one fraction and this 2 is a numerator of another fraction. So you have to multiply it, we get 4. And we again multiply the numerator of this fraction and denominator of this other fraction. We get also 4. When you get the same value, when the numerator and denominator of another fraction multiply, you get the same value. So you can say these two fractions are equivalent. In this way, we can identify the equivalent fraction. So we have to remember it, the product of the numerator of one fraction with the denominator of other equivalent fraction are same. Then we can say they are equivalent fraction. You see that there is some math to identify the equivalent fraction. So 4 and 3. At first you have to multiply 4 into 3. We get 12. When we multiply 2 and 6, we get 12. So they are equivalent fraction. When we multiply 6 and 4, we get 24. When we multiply 3 and 8, we get also 24. So it's also equivalent fraction. In this way, we can identify the equivalent fraction. There is another math, you can practice it. 4 and 5 and 5 and 10. When you multiply, you get same value, so they are equivalent fraction. Another way to multiply, find out the equivalent fraction, that means half. There is numerator 1 and denominator 2. You multiply the numerator and denominator in the same value, that means 2. We multiply by 2 the 1, we multiply 2 with the 2. Same value. We multiply the numerator and denominator with the same value 2. We get the fraction 2 by 4. So this will be the equivalent to 1 by half, because it we will get the 2 by 4 by multiplying the same value 2 with the numerator and denominator of a fraction. So this fraction will be the equivalent fraction. In this way, we also can identify the equivalent fraction. There is some practice. We can identify the equivalent fraction. When we multiply the 1 with 3, we get 3. And multiply the 2 by 2 into 3, we get 6. So 3 by 6 is also equivalent fraction to the half. In this way, you can find it, and other math you can solve it by any way. Number 9, that you can find equivalent fraction 1 by 3rd and 1 by 4 by using same method like above. You can practice in your home. Here you have to write the equivalent fraction in the blank. There is example of 2. You can find that equivalent fraction 4 by 6. 4 by 6 we get when 2 multiply with the 2 and 2 multiply with the 3. We get 4 by 6. When 3 multiply with the 2, we get 6. 3 multiply with the 3, we get 9. When 4 multiply with the 2, we get 8. And 4 multiply with the 3, we get 12. When 5 multiply with the 2, we get 10. And 5 multiply with the 3, we get 15. So same number multiply with the numerator, denominator, we identify the equivalent fraction. When we multiply the 6 with the 2, we get 12. When we multiply the 6 with the 3, we get 18. When we multiply the 7 with the 2, we get 14. When multiply the 7 with the 3, we get 21. So these all are equivalent fraction with the 2 by 3. In this way, you have to identify the equivalent fraction of 3 by 4, equivalent fraction of 2 by 5, equivalent fraction of 1 by 6, equivalent fraction of 1 by 7. This is for your home practice. You can practice and identify in your script or in your copy by in this way, following this rule. Same number multiply with the numerator and denominator, you can identify it. So next math, check the following pairs of the fractions are equivalent or not. If they are equivalent, you have to tick mark. Whether they are not equivalent or not, you have to tick mark the not equivalent not. There is two fraction in the first box. You see that there is 2 by 5 and there is 4 by 10. They are equivalent. So we have to solve in this way. We have to multiply 2 with the 10 and 5 with the 4. That means the denominator of one fraction and the numerator of other fraction, and the numerator of one fraction, denominator to one fraction. So when we multiply the 2 and 10, we get 20, and multiply the 4 by 5, we get 20. So these are equivalent. And the next one, we have to multiply 2 with the 5 and 3 with the 3. When we multiply 3 with the 3, we get 9. And when we multiply the 2 and 5, we get 10. So they are not equivalent because we do not get same value. So you have to tick mark the not equivalent row. In this way, you can solve this types of math. This is also for your home practice. You can solve in your home. So in the next math, do ourselves. Write a fraction which have indicated denominator and numerator. And number 1, numerator 5 and denominator numerator 2 and denominator 5. So 2 will be upper level of the fraction line and 5 will be lower level of the fraction line. Denominator, in this way you can solve it. We can write number 1, 2 and 5. We can write for number 2 here 9 will be lower part and 5 will be upper part. In this way, this is for number 2 and this is for 1. In this way, we can solve, we can make our fractions. Find the equivalent fraction of the following fraction. You have to find out the equivalent fraction. So you have to find it the same number. I will practice 1, same number, multiply with the 1 and 5. So we multiply the 2. When we multiply the 2 with 1, we get 2, and multiply to 5, we get the 10. When we multiply the 3, we get 3. When we multiply the 5, 3, we get 15. When we multiply the 4 with the 1, we get 4. When we multiply the 4 with the 5, we get 20. So these all 4 fractions are equivalent fractions. In this way, you can identify or find out the other equivalent fraction of the rest too. So in this way, you can save it, and you also in your books, you can find it in your books, so you can solve it in your home practice in this way. Next math. Check the following pairs or fractions are equivalent or not. Write calculations and tick whether equivalent or not. This is also the previous slide. You have to multiply the numerator and denominator. You have to show the calculation in this box. In this box, you have to show the calculation in this box. Sorry. You have to calculation in show in this box, and tick you write tick marks if equivalent or not equivalent. You have to practice in your home to find out the equivalent and not equivalent fractions. compare the following pair fraction, which is greater and which is smaller. Here is a technique. You see that number one, two fraction has the same denominator. In this fraction have a same denominator, which numerator is large, which fraction is large. So here one numerator is 1 and 3, so 3 is large or greater, so 3 by 4 is also greater. Here you see that the two fraction, the denominator is 5, so here is 2 and here is 1, so 2 by 5 is larger. Here 2 denominator is 7, so here is 5 and here is 4, so 5 by 7 will be greater. Here 1 is integer and 8 by 9 is a fraction. You see that 8 is smaller than that of 9. When we divided the 8 by 9, we get a fraction. At first we take a point and there will be 80. Then we can write 8. There will be 72 and remain 8. So we get 0.8 and here will be 1. So 1 obviously greater than that of 8 by 9. There is 1 minute, less than 1 minute. I will go our question section. Here is fraction already finished. In the remaining part and the geometry. In the next class, we will discuss our geometry and remaining part of the fractions. If you have any question, you can ask me.
Yes, sir. I have.